About 13.8 billion years ago, the universe was born in an event we call the Big Bang. It was not an explosion in space, it was the expansion of space itself. In less than a second, the cosmos went from smaller than an atom to larger than a galaxy. Matter, energy, and time itself all emerged from that moment. From there, stars ignited, galaxies formed, and eventually we appeared to ask the question, if it all began, how will it all end? The universe had a beginning, it may also have an end. But how, or even if, it will truly end remains one of the greatest mysteries in science. Some theories suggest the cosmos is destined for a final fate, while others leave the door open for possibilities we have not yet imagined. What we do know is that the universe's future depends on the same forces that shaped its past: gravity, dark matter, and dark energy. So what do scientists really think will happen? In this video we are going to dive into the possible endings of the universe, so let's explore. The Big Rip. When the Big Bang happened 13.8 billion years ago, space itself began expanding, and it never stopped. We first uncovered this expansion in the 1920s through the combined efforts of several scientists. Vestos Slipper measured the redshifts of distant nebulae, objects we later confirmed were entire galaxies beyond our own. Together their work revealed one of the most profound truths in science: the universe itself is expanding. Here's what that means. Light travels in waves, and these waves carry energy. As the universe expands, the space between galaxies stretches, and the light traveling through it stretches too. Stretching the light wave makes it longer and lower in energy, which we perceive as radar. A simple way to imagine it is like pulling on a slinky. As you stretch it, the coils move farther apart. That's similar to how light waves stretch across the expanding universe. This redshift was the first clear evidence that the universe is expanding. Decades later, astronomers discovered something even stranger. The expansion is not slowing down, it's speeding up. This acceleration is driven by something we call dark energy, a mysterious force making up nearly 70% of the universe. And it's important to understand that space is not expanding into something else. There's no outside, no edge. Space itself is stretching, carrying galaxies farther and farther apart. But not everything stretches. Galaxies, stars, and planets stay intact because gravity holds them together. Only on scales larger than galaxies does the expansion dominate. If this acceleration continues unchecked, the future gets stranger. Galaxies will drift so far apart that billions of years from now, the night sky will grow empty, no more galaxies visible beyond our own. But it does not stop there. If dark energy grows stronger over time, it could eventually overcome gravity itself. In about 22 billion years, this runaway expansion would reach its climax. First, galaxies themselves would be ripped apart, then planets would be torn from their solar systems. Stars would follow, shredded from within, and even atoms themselves would be dismantled. Space-time itself would rip apart, and with it, time as we know it would cease to exist. This is a vision of the Big Rip, a universe literally torn to pieces by its own expansion. The Big Crunch. While the universe is expanding now, some scientists have imagined an opposite fate: the Big Crunch. In this scenario, gravity eventually wins. If the total amount of matter in the universe is enough, it could slow and stop the expansion. Then, instead of drifting apart, galaxies, stars, and planets would start falling back toward each other. Over billions of years, the universe would shrink. Galaxies would collide, stars would merge or explode, and cosmic structures would be compressed. The night sky would become crowded with glowing galaxies and swirling clouds of gas. Eventually everything, every star, every planet, every particle, could collapse into a single, unimaginably dense point, the reverse of the Big Bang. Big Bounce. Some scientists imagine that the Big Crunch might not be the ultimate end, but instead the beginning of something new. In this scenario, the collapse of the universe could trigger another Big Bang, giving rise to what's known as a Big Bounce. The cosmos would contract, rebound, and expand again, an endless cycle of deaths and rebirths, a cosmic loop without a true beginning or end. Heat death. Unlike the dramatic Big Rip or the collapsing Big Crunch, the heat death, also known as a Big Freeze, is a slow, quiet fading of the universe. In this scenario, the cosmos keeps expanding forever, but not violently. Galaxies drift apart, interstellar gas thins, and eventually new stars stop forming. Most galaxies will become dominated by small, faint red dwarf stars, quietly burning for trillions of years. Over unimaginable timescales, even these stars will burn out. Black holes, some supermassive, others smaller, will slowly evaporate through Hawking radiation, leaving behind only a thin, diffuse soup of particles and radiation. This is the universe reaching maximum entropy, a state of thermodynamic equilibrium where energy is evenly spread, no work can be done, and motion ceases. The cosmos becomes dark, cold, and lifeless. It's important to note how this differs from the Big Rip. Heat death happens if the universe expands forever at a steady or slowly accelerating rate, letting galaxies, stars, and atoms remain intact as the universe slowly fades. The Big Rip, on the other hand, would occur if dark energy grows stronger over time, accelerating expansion so violently that galaxies, stars, planets, and even atoms are torn apart. Heat death is a quiet, gradual fading. The Big Rip is the extreme, destructive tearing apart. The idea of heat death dates back to the 18th and 19th centuries. French astronomer Jean-Sylvain Bailly first suggested that planets and stars gradually cool over time, and Lord Kelvin later applied the laws of thermodynamics to the universe itself. Kelvin realized that energy dissipates over time, leading to a gradual running down of the cosmos, a universal clock winding to a stop. According to modern cosmology, if the universe continues expanding forever, as observations of dark energy suggest, heat death is a most likely fate. Black holes could take up to 10 to the 106 years to evaporate, after which the universe enters a dark era consisting of only diffuse radiation and subatomic particles. Over even more extreme timescales, spontaneous quantum fluctuations might in theory create new structures or universes, but such events are extraordinarily improbable. Heat death is not violent, it's the ultimate stillness, a universe where stars die, black holes vanish, and the cosmos drifts silently toward infinity, frozen in darkness. Other possibilities. Beyond the Big Rip, Big Crunch, and heat death, scientists have imagined even stranger endings. Some theories suggest the universe could experience a false vacuum decay, where a sudden shift in the vacuum state triggers a bubble of destruction traveling at the speed of light, rewriting the laws of physics as it goes. Others imagine there's even the idea that our universe could be just one of countless multiverses, and a collision or interaction with another universe could bring dramatic change. While these ideas are highly speculative, they remind us that the cosmos is full of mysteries, and the ultimate fate of everything remains an open question. Thank you for watching Planet Spiral. Please like this video and subscribe to this channel, and I will see you in the next one.